Hello, I'm Sam Lopez, European Sales Manager for Matrox Imaging. We're a Canadian company. We've been around and doing this for 33 years now. And what we'd like to do today is just take you through some of the highlights, I guess, of new products being introduced at the Vision Show here in Stuttgart. Right behind me here is a station where we're introducing the new release of Design Assistant version 2.2. The Iris GT, our smart camera, basically makes use of this software, enabling you to develop applications. And what we've got on this station is demoing two modules, if you will, of Design Assistant. On the first side, you've got a bead inspection application. This is basically an application mainly used in the automotive industry. You've all seen this when installing windshields on a car. You've got a bead of glue basically that's inserted on the perimeter of that frame, and the windshield basically gets inserted. They actually have to inspect that bead of glue, making sure that there aren't any gaps or any discontinuities along that bead. And over here on the monitor you can see a sample, a short and small sample, but nevertheless gives you a good feeling for what the bead inspection application does. On the left-hand side, you've got a typical OCV or character verification system, and what we're doing there is just simply reading this character or these printouts on the vials that are underneath this turntable, and basically verifying that the date codes and lot codes are correct. So just two very quick and simple examples showing the power of the Iris GT. What I'd like to show now is a spin-off, basically. We started with the Iris GT. From the Iris GT, we come to the Iris or the Gator Eye, which is our version of a IP67 GigE vision camera. The main point to retain here is that it is an IP67, so a ruggedized enclosure for this camera. The purpose of that, of course, or the main utilization of this is in industrial environments, typically factory floors where you've got a lot of dust, you've got a lot of contaminants. You're trying to protect your camera and trying to keep it basically dry and clean. So the enclosure, of course, allows you to wash it down. Very useful when working in a food processing type of environment or a pharmaceutical type of environment where this type of camera is mostly going to be used. In this demo, we're also highlighting the capabilities of MIL, again, the software that drives these devices. So what we've got in this demo over here is a laser line being scanned across two sample items here, two objects, and we're creating a profile. The profile basically gives you a depth map of the object under inspection, and we're using that then to do basic measurements. In the example we've got here, you've got a good sample and a bad or a defective sample. And what we're looking at here is basically the profile shows the good sample, and very quickly you're able to identify the gap there, which is obviously the defect that we're looking for. All of this is done within MIL, and of course we're using our world-famous Foresight X to do the actual processing. I'd like to show you now the Matrox SuperSight. This is our high-end industrial computing platform, and the unique features of this product is basically a PCIe backplane, segmented backplane that allows you to insert multiple CPU cards, GPU cards, and of course frame grabbers for your video acquisition. And in this demonstration, what we're showing is the SuperSight loaded with all three of those technologies. The front end being a Radiant frame grabber card, which is our acquisition and pre-processing card in this case. And of course several GPU and CPU cards, each one of those forming what we call a cluster to allow us to do processing on several images, or if you will, images coming from this camera at the same time or simultaneously. We've got a line scan camera here from Basler, and it is focused on this rotating drum, which is holding a strip of actual postage stamps. And each frame is successively acquired, but then simultaneously sent to a separate node in the system to actually do the processing simultaneously. If you look at the display over here, on the left-hand side, you see the actual acquired image, and what we're doing is within the Radiance FPGA, we're using the FPGA to do a correction on the fact that the camera is not perfectly perpendicular to the drum, so you're getting a parallax effect, and what we're doing is we're correcting it. Of course, then on the right-hand side, all we're doing there is using some simple blob analysis to detect the perforations of each between the stamps and detecting whether all the perforations are in fact the way they normally should be. So there you have it. We're showing the SuperSight capabilities and its ability to house multiple technologies, and all using the same Matrox Imaging library to program and use it.